How's everybody today? All fired up with you after the yoga, right? I missed out on that one. So we'll talk about the endocrine system, and anybody has any idea about the endocrine system? Let's keep it. Me also, a little bit only. I have to rely on these slides. So let's start with the reverse question. What would happen if we didn't have an endocrine system?
No hormones?
Metabolism.
No hormones? Is that what it does? Hormones? Body will not function.
How?
Body will not function.
Yeah,
Yes.
why? What is the importance of the endocrine system?
Because
I mean, we have every other system. We have the nervous system. We have all of these systems.
So pituitary gland is the master gland where all hormones starts from there.
Mm-hmm.
So if the pituitary gland and there is no heart, there is no secretion happening. So
Mhm.
even you have the organ, but there will be no flow, there will be no signal going on there.
So what do you need the signal for? What signal?
So which signal to what? So like suppose you have a kidney and then you have endocrine system on the kidney to function it well. Then your pancreas, then all these master gland is hormones are coming from there, TSH, FSH, so all the stimulation will not happen.
The stimulation of what?
For all the even your reproductive system,
For the functions.
vaginal, everything, it will not function
Yeah.
if the master gland is not working or the whole endocrine system.
So it's like a factory which has everything, but there's no coordination, there's no working, there's nobody's finding out what is going on in the factory, what is being produced, what is not. If each organ just does its own thing, then you're just going to there's going to be no control. So the endocrine system is a different way, another way of the body to control, to control body functions, right? How if you become too hot, if someone has a fever, they start breaking into a sweat. How do they do that? It's through the endocrine system. Somehow some signal goes in saying, okay, this is at body temperature. Then something happens somewhere that makes the body change that and makes the person sweat and reduce the body temperature, right? So then when somebody is hungry, again, it's basically how the actual operations of the body cannot function without the endocrine system. So when there are endocrine system disorders, that's when you can see there are some problems that people have, some certain diseases or conditions that don't allow that person to function normally, right? So it is a very, very important, it's sort of subtle, but it's like a link for everything in the body. So one of the objectives of this talk is to just kind of know, to get an overview of it's really important to understand what the endocrine system does, how important it is and what it does, and then we can get a little bit more specific about that. So endocrine system, endocrine means it means secretion inside the body. So you're exactly right. Something in the endocrine system is interesting that most of the body secretions of the endocrine system is just poured into the bloodstream. And when that happens, when it's poured into the circulatory system, that actually goes everywhere. It circulates all throughout the body, right? So the organs of these, they secrete, they synthesize certain hormones and chemicals. So it's a way of chemically adjusting the body functions. Okay, and the secretions of these glands, they don't leave the gland by a duct. So usually they are called ductless. They just diffuse out and get into the bloodstream. There are certain duct glands that have ducts, like the salivary glands. They have a certain structure, they have a certain shape, and then they have a tube that comes out of it that goes into the target area. That is only meant to it has an opening into the mouth, right? Those have ducts. Ducts are those conduits that convey the fluids in. And in fact, it's interesting, one of the glands, the pancreas, in fact, is an endocrine gland, but it is sort of also an exocrine gland. It also it has a duct system that also sends stuff into the intestines. Um, so the structure of the endocrine system. Now, these are the components of the endocrine system. There are the hypothalamus. There is a connection between. So the endocrine system is like the chemical system of the body, right? And the nervous system is like the electrical system of the body. Although it's very closely connected, the nervous system cannot function without chemicals because the neurotransmitters are chemicals that happen. That's how the nerve impulses go along the nerves, and then when they are transmitted from one nerve to the next nerve or to the next thing, there is a junction where there is a exchange of chemical exchange that changes the whole ionic composition, for the electrical impulses to move on. So the hypothalamus is actually, you're right, the pituitary gland is the master gland, but even the master gland, which is again, pituitary is a very it's a chemical gland. The hypothalamus is that part of the brain that actually is what controls the pituitary gland. So the interesting part about this system is there are so many levels of control. If one level fails, all the other levels can fail. It's not direct. The hypothalamus sends messages to the pituitary. It secretes some things that triggers the pituitary to secrete something. Then what the pituitary secretes then influences, say, the thyroid. Then that's what happens. Then when the thyroid ultimately secretes its stuff, that's when the actual action that's supposed to do happens. So it's not direct. It's not a direct action. It's a very indirect action. One thing controlling the other. So the hypothalamus is part of the endocrine system. And then you have a whole bunch of glands within the brain, underneath the brain itself. You have the pineal gland, that is a small, tiny gland in the back of the brain. And that one actually has to do with sleep, how it induces sleep. Then you have the pituitary gland. So these are the three main in the head area. Then in the throat area, you have the thyroid. Everybody knows if you have a thyroid condition, hypothyroidism and hyperthyroidism, right? And we'll talk about what the function is. And then you have the parathyroids. The parathyroids they also are within the thyroid muscles. There are 4 parathyroid glands that sit within there. Then below that, where the lungs sort of meet, where the 2 lungs, they send off the bronchi and they meet somewhere in that area, there is a gland called the thymus gland. Okay, that also has a specific function. Each gland has a specific function in the body and they coordinate with each other. Then as you come down into the abdominal cavity, you do have the liver is here listed as part of the endocrine system, and that's where a lot of places I've seen liver is not listed, but the liver actually does have a very close connection with the endocrine system. It interacts very closely to regulate the blood sugar and to regulate a lot of the functions. Then the kidneys also excretes a few chemicals that that has to do with working with a little bit of the blood pressure problems that people can have. And then on top of the kidneys there are two kidneys, right? On top of the kidneys there are 2 glands called the adrenal glands. They're very important glands in connection with again the system over here, and they secrete usually the fight or flight. The sympathetic response is very closely coordinated with the adrenal glands. Then you have the pancreas, of course, which regulate the blood sugar. Mostly we know the pancreas as only for blood sugar, but it has some other functions also. Then you have the ovaries or the gonadal. The gonads are the sex organs. The ovaries or the testes. The ovaries in the females and the testes in the males. And they also produce the female, the estrogen, and the males, they produce this testosterone. So we went there, and then over here even the placenta is considered, so it's basically a bunch of tissues that secrete a certain chemical that is targeted for a specific purpose. Usually it's a purpose. And then if one hormone reduces the say the water content in the blood, the other hormone, there may be an opposing one that actually tries to balance it out. So the endocrine system, not only does it work on the smooth functioning of the body. It works on getting the body to attain homeostasis. Homeostasis is a very important word because it means that when something happens, there's a counteraction to balance it out. Homeostasis is a balance of the body. Every time anything happens in the body is striving to get everything back to neutral, to a normal level, to homeostatic level, where it's not either, it's like a pH. The pH is not too high or too low. It's just the right amount. That's exactly that's exactly what happens.
Quick question. So I noticed in that list we didn't have the thymus gland. So I was wondering, like, one of the things that I read was that the thymus is not active for adults.
I don't know about that. I know that it is very active in an adolescent. I think it gets activated in teenagers to get the immune system working better. But I'm not sure about that, whether it's not active. Do you know? Does anybody know? I didn't realize that.
Yeah, even I read somewhere it's not very functional in adult. It's
considered.
It-
There is a very
it's
controversial report. Sometimes they say it helps in calcium formations and
Yeah.
stuff. So it's,
Or
It's very
it
hazy.
produces those
Yeah.
T cells or something, right?
yeah.
For
Yeah.
it makes the white blood cells mature to be ready to fight infections.
Yeah.
So for viruses, and what I read was that it's very active in adolescent, or rather it's developed well at those puberty years.
There is a very hazy report, confusing. But
Oh.
that's probably why it was not
So now we talked so much about the nervous system, right? The sympathetic nervous system, and we think the sympathetic nervous system is what causes the sympathetic response versus the parasympathetic response and all of that, right? So, but there is a very close connection. The nervous system does not act by itself. Nervous system needs chemicals to to do its work, and vice versa. The chemicals also, the nervous system also triggers the endocrine system to produce certain chemicals to produce a certain kind of response in the body, right? So what does the nervous system do? The nervous system maintains the homeostasis through nerve impulses. Okay, so it said the hypothalamus is part of the nervous system actually, but it is still considered, it's the bridge between the nervous system and the endocrine system, right? So what does the endocrine system do? It also tries to maintain homeostasis, but through the hormonal system, through chemicals. And again, it's a very artificial distinction because they work in collaboration with each other and talking to each other, and they're dependent on each other. Because like I said, a nerve impulse cannot continue without having, for example, one of the products of the adrenal glands is norepinephrine, and the nervous system some of the nervous system uses norepinephrine to convey the electrical impulses from one nerve to another, to convey its messages. So you still need the same hormone to conduct the nerve impulses. So the difference, again, nerve impulses, the nervous system, there's one important distinction. When the nervous system acts on, like through the vagus nerve, it acts in a very specific channel, going to a very specific targeted area, right? But what does the endocrine system do? It acts it's poured into the bloodstream. So it goes to all parts of the body, right? However, we'll talk about the endocrine system also ends up being a targeted system. Okay? For example, if it is targeting the pancreas, that same hormone that is targeting say the pancreas is not going to work on the kidneys. It's something else that will work on the kidneys. It has to match the organ that it targets. So the nervous system can only act on neurons, muscle cells, and glandular cells. It basically works on muscles to cause a contraction in a gland even, and that contraction can make, can kind of squeeze out the fluid from the gland, right? So, and it also works on the muscle cells, the skeletal muscle cells. The endocrine system works on all cells. It has an effect on every cell of the body. Because it's again, and then again it's a long-acting system. So what are the role of hormones and homeostasis? there is a feedback mechanism, right? There's too much of glucose in your blood, right? That chemically gets transmitted to the hypothalamus. Okay, there's too much of, or the pancreas, right? So then some adjustment has to happen. Something has to tell the pancreas, okay, stop, producing so much insulin. Something has to tell the pancreas, produce more glucagon. Let's reduce this blood sugar, or let's increase it. So there's always a balance, and that balance happens through the chemical sensors. They like the chemical part of the blood is tested at every point to see what is that. Is the blood is there too much water in the blood? Is the blood too thick? Or is there, is it too thin, or is it too thick? So basically to adjust those levels. So the other thing that happens is, like I said in the beginning, the hormones, the endocrine system does not act. There's not one gland that acts. It's a very indirect system. So one gland gland A will act on gland B to produce something that can act on gland C. And then gland C might be producing the actual hormone. And again, the nerve stimulation can cause hormone stimulation. So you can have the hypothalamus, the nerve can actually send something to say, okay, let's get this going. And then something gets secreted, and somehow, so that gland can be stimulated also by the nervous system, by the vagus nerve or other nerves that connect each other. So then we're the pituitary gland. This is the master gland. This is a gland that has a lot of, it secretes a whole bunch of hormones that are targeted to different parts of different endocrine glands. Okay, and it's located inside the brain area, in the front. Then you have the pineal gland that is in the back, a little bit in the back. The pineal gland is one that secretes. It's right now what they think is it secretes melatonin that makes you sleepy, that makes you go to sleep at night. So it also can control your circadian rhythm at night when you sleep. The rhythm of the body. You wake up in the morning and you're more active in the morning, and then by the time you're in the evening, you start becoming tired and sleepy, and then you ultimately need to sleep. So that's the whole rhythm of your body.
Activity of pineal gland also depends on the age of the body. Like in the kids, it might be more active because kids sleep throughout, and then I think teenage has different rhythm.
Probably, it has. It gets more mature. In the child, everything is still developing, right? The whole nervous system is not completely mature in the child, so it's probably happening parallel to that. So the child's rhythm is not set in the beginning, or the child may need to sleep more, and maybe that's when the pineal gland gets more stimulated to say, okay, let's So the rhythm can change. I'm sure there's. So I don't know specific information about that, but it kind of makes sense.
But it's not get regulated by the pituitary gland. It's just like independent.
The pineal gland? I'm not sure about that. If the pineal gland is directly stimulated by the pituitary, I don't have information on that. I don't know. Anybody knows?
I don't think so.
I think So I don't know if it has a connection with the hypothalamus that is telling the pineal gland. So your question is, does the pineal gland spontaneously?
Yeah, it does by itself.
Does by itself, or is it getting a
like
message?
Pituitary, gives all this stimulating hormone to work on different organs.
Correct.
What about the pineal gland?
Yeah, it's a good question, and I don't know the answer.
We'll find. Okay.
Yeah. Who's taking that up to
I
find
can.
out? Okay.
Yeah, should I?
Okay. So hormones of the pituitary gland. There is the HGH hormone, the growth hormone, right? Then there is the thyroid stimulating hormone. So the pituitary gland sends out this hormone that. So just remember that the pituitary gland just has this whole bunch of different chemicals it's pouring into the bloodstream. So each of the chemicals is only targeting a certain area. So the receptor for that chemical is only there present in, for example, the TSH, the thyroid stimulating hormone. The receptors for that hormone is only present in the thyroid. So if that hormone goes to the pancreas, it's not going to do anything to that. It's going to ignore. or to the kidneys or to the adrenal. It will only be accepted at the thyroid level. Seems like a waste, right? It's like there could have been a direct connection. Then it has the follicle stimulating hormone for the gonads. The gonads are again the male and female, the sex organs that produce the corresponding hormones to evoke the development of those sexual characteristics of a male and a female. Then you have the luteinizing and prolactin and oxytocin. Again, there are some special hormones that are secreted during childbirth and then during lactation, so that to produce milk, and then during labor, the oxytocin, so that labor you need to send a whole bunch of chemicals that makes the ovary start contracting to push the baby out. So that's also controlled ultimately by the pituitary gland. Then you have the ACTH, the adrenocorticotropic hormone, which are secreted again by the pituitary gland. And again, this again is an indirect effect. It indirectly goes to the adrenal glands, and there it can stimulate the release of cortisone and certain kind of steroids that are made within the body. You have steroids that are artificially made that we have, but our body is a huge factory that produces steroids by itself. Okay, and then you have the anti-diuretic hormone. So a diuretic is something that reduces the water in the blood, usually through the kidneys, right? If you take a diuretic, that means you're passing out more water, and so this is an anti-diuretic. So it does not want the body to lose too much water, so it might regulate. So if there's more anti-diuretic hormone in the blood, it will withhold the water. If there is less, then it will allow the water to pass through, right? So that's how it can regulate, by adjusting the amount that it secretes.
Jyoti, just wanted to add a little bit here because we are so much into stress and its effects. When one is stressed, the body tries to retain the water. That is one of the reasons why the necessity comes, right? That is the question. And also to control the blood pressure. Can you just talk about
So again, the volume of the blood, there's only a certain amount of space, and if the volume of the blood increases, it's going to increase the blood pressure, right? Either the volume increases by there being a lot of water there, or swelling, or it can increase by, or you can have high blood pressure because you have the walls of the arteries themselves are narrower. Either way, if the volume is more, then the pressure is more. So then to reduce the pressure, then they may have to secrete more water out. So that adjustment. So again, if someone is stressed, they hold the water, their heart rate goes up, the heart is pumping crazily, there's more volume of water or blood circulating, and then there's a lot of water around, increases their blood pressure. So something has to be done to change that. So disorders of the pituitary gland, there's something called hyperglycemia, where the beta cells are what produce the insulin in the pancreas, right? And if the beta cells are burned out, so this is a disorder it's not a direct disorder of the pancreas. This is indirectly the production of insulin is affected from the pituitary. If there's a pituitary gland tumor or something, that may then not allow the pancreas to secrete insulin because it may cause the beta cell burnout.
Hyperglycemia is less because of less sugar in the body.
The what?
Less sugar in the body and more sugar of the body. Hyperglycemia. When does it happen?
So insulin is meant to reduce the blood sugar off.
Yes.
The circulating sugar in the blood. Okay, so that's what insulin does. When insulin is poured through the pancreas into the bloodstream, the number of blood, the glucose comes down in the blood, and the glucose goes into the cells, right? So they're going to be used up by the muscle cells or whatever. So if something is not allowing insulin, if there's not enough insulin in the blood, then the blood sugar will be high. So it will cause, so what they're saying is this particular disorder called hyperglycemia of the pituitary gland can cause high blood sugar.
So basically, diabetes doesn't necessarily mean it has only one cause. There are many causes to diabetes, and one of them is
Yeah.
the
So it's, usually we hear so much, everything is about the pancreas with diabetes, right? Something's wrong with the pancreas. It's not secreting enough insulin, something is happening. But yeah, it may not be secreting enough insulin, maybe directly because something is wrong with it, or indirectly because of the pituitary gland. Again, it's a good point of showing how the pituitary controls the other glands. And if something is wrong at that level, it can percolate to the other levels.
And also, this is about the system as such, not yet disorders. So we'll have one probably just on all the endocrine disorders, because the list of disorders just coming out of pituitary malfunction is enormous.
Yeah.
Because the number of
Because it just does so much.
yeah.
So
Can I ask,
it's
because we are in this topic of the pituitary and dysfunction of the pituitary can affect other hormones. I read an analogy. I just want your comment on that. Like, it gave the picture of the pituitary as a switchboard and the hypothalamus as someone who's trying to regulate different electrical devices using the switchboard.
I see.
And each of the electrical equipment is the endocrine
Is
gland.
it? That's a great analogy.
Mm.
Yeah.
So pituitary is the switchboard?
Yeah. In that one control box, you can control all the
Everything.
endocrine glands.
But
The hypothalamus is the guy who's controlling it.
oh, the guy is.
And there is all kinds of disorder. The one that we talked about previously, that is, it's diabetes insipidus. So we talk about diabetes mellitus, and this one is diabetes insipidus. So
Where pituitary is involved.
pituitary caused diabetes. So that's why when you go with diabetes, they will do a bunch of tests initially to see what is.
So the testing, then you come to know whether it is insipidus or whether it is.
Yeah.
Oh, okay. So that's
And
a
typically, I
specific-
don't know when insipidus is, what the age of onset is for insipidus. Is it there? But for mellitus, if it's a type 2, of
Yeah.
course you can have the type 1, which
Yeah.
happens in adolescent and
Yeah.
children,
Children.
right? Children can get diabetes.
Yeah,
That's a big deal right now. It is there.
yeah.
It is a thing. And then, but there's a very common diabetes that we generally talk about is adult onset. So we don't have the diabetes at all until we're a certain age.
Right.
We start entering our 40s and 50s and we start discovering that we are not processing our blood sugar properly. Our blood sugar is not being regulated properly. And that is the diabetes type 2. That's more adult onset. So parathyroid, thyroid and thyroid is right there. The thyroid gland is right there, just around your throat area. And it has two, it's like a butterfly shape. The thyroid is a butterfly shaped organ with two parts connected in the center of the two parts of the trachea and connected in the middle, right across. You can actually palpate the thyroid gland. The parathyroid glands are embedded inside the thyroid and there's 4 of them, 2 on each of the lobes of the thyroid. And they actually do sort of slightly opposing functions, actually a little bit. So hormones of the thyroid gland, what do they do? So the thyroid gland is very important in regulating the basal metabolic rate. Anybody know what the basal metabolic rate is? Idea?
Other than it's a number.
No, don't worry about the number, the concept of it. What is-
How fast
Digestion,
your
fast your body.
how fast your
Yeah.
glucose molecules are.
Yeah, like the base level. When you're at rest, there's a certain level of metabolic activity that still has to happen in your body. That's your base level of metabolism. Some people are not doing anything and they're burning a lot of energy. You know, it depends on different people, and some people need more. You know, people have different basal metabolic rates based on, I don't know, I guess their genetics or just how everything is wired up in their body. And so that is the basal. So the hormones of the thyroid gland can regulate the basal metabolic rate. It can help make it either high or low or keep it at a certain level. Uh, the thyroid is very important in bone growth, especially the long bones. The growth of a body, it stimulates the multiplication of the cells of each type of cell to become big and long and strong, like the bones, like the muscles. So somebody who's I saw a picture of this guy who was the tallest man, was some 8 feet tall. I forget his name. And have you seen that? So, huh?
In Pakistan.
Oh, is it Pakistan?
Yeah.
Really? Now? No. So this is a more historical finding, and they gave it a name. The medical people gave it a name. It's because he was 8 something tall, and because he had a problem with the thyroid. And he just kept producing growth hormone, and he just kept producing it. So his bones became longer and longer, and his body, other functions could not even sustain that. So he ended up dying at a younger age because everything was just grew just so much.
Pakistan guy. He died already.
How, at what age?
Maybe it's a secret.
Very young.
Yeah, it's a young person.
Oh, is that right?
Yeah.
Yeah.
I'm reading that because I'm a short person. I was like, imagining the problems he might have.
Yeah.
He
Yeah.
was 7.5 feet or something like that.
So yeah, so this particular one that they based this example on, I read this recently, was this extra tall, 8 something guy, huge guy, and he couldn't survive for a long time.
So is dwarfism the opposite?
I guess, I mean, it's probably the bones are not growing, because dwarfism, everything else functions fine, it's just that they're not tall, right? So it's probably that they don't have enough of the TSH or something that makes their bones grow at that specific age.
Can I ask a quick question? So when we are talking about the basal metabolic rate, one of the things that I've heard in the yoga community that to target, for example, obesity, like how to balance the body weight, in addition to giving a lot of aerobics and burning calories, one of the things they say is doing some practices that massage the thyroid, like the sarvangasana and so forth. How scientific is that, or is there a fundamental basis, truth to that claim?
I don't know, because I mean, in a way, you can think of it as, and correct me, she's the yoga guru here. So,
There is yoga guru here also.
So, I think it's the mechanical effect of, I think ultimately, if you think of it, if I think of it, ultimately everything in the body there's something mechanical going on. Even a chemical exchange between going through the cell membranes, it has to do with the size of the pores. It has to do with size, and if the size is big enough for something to pass through, it can pass through. It has to do, there's a lot of mechanical things that happen at the cellular level, which, we don't look at it as mechanics, but it is, right? So I think even with this, you have, you have a pulling, you make space. In a way, I think the way you can think of yoga, the way I think of yoga is you make space and you open up certain spaces that have been cramped. And when you open it up, something happens. Maybe that cell opens up, which has been suppressed, or maybe when you press it, it compresses and secretes something better. So maybe it's the compression and release of that. They say even Sarvangasana is very good for the thyroid, right?
Even Ujjayi breathing, they say.
And that's
Yeah.
probably during Ujjayi that heat is produced in the body. Is it produced in the body when you do Ujjayi? And is that kind of
That is
going to help in your...
So I think a lot of the yoga claims have to be corroborated with research, and it's hard to do that because you first of all need very controlled, in today's research climate, everything you have to have a controlled study. You have to control all the other factors and check only one, and that's incredibly difficult. The body is so complex that, I mean, there are some hypotheses that we can all have, and I think that's what a lot of the yoga community is based on. It makes sense. It's empirical, just hypotheses. It's like this because this influences this, because this, because this, because this, right? But is there an actual proof? They're coming up with more proof, but it's more general. It's like when you do yoga, when you do meditation, they're checking the cortisol levels and they're saying it is low, right? So, and then how they do, so it depends on how you design that experiment to check out a hypothesis. You have a hypothesis, then you have to check it out. How are you going to design that way to find out what is the truth, right? So it's one of those things.
And in yoga's case, there is some amount of physiological benefit in the sense, some amount of physiological action is happening, some amount of intention is being built because you are now thinking of that area, and then you feel a surge of prana enters into your area, and all that is a very mental exercise which differs from person to person also. In case of research,
Exactly.
the same practice may yield different results because one person took it very faithfully and did it, versus the other person said okay whatever and they did it. So
Yeah.
that also matters. So how do you experiment that?
Yeah. And you need the right sample size, you need enough people in that controlled study to follow. So, and because a lot of the yoga stuff is lifestyle, it's a long-term effect, right? Somebody, you say, you can't control 1,000 people, you say go do yoga, somebody might do it at 8 o'clock, somebody might do it at 10 o'clock, somebody might not be sincere in doing it but still say they did it, right? Compliance, there's so many factors that can confound the study and make it less valid. Versus in a lab, you can control the rats like really well, and right, it's just a hard thing.
Rat yoga.
Rat yoga, right? Yeah. So the hormones of the thyroid also have to do with carbohydrate, fat, and enzyme metabolism and glucose intake, uptake. And then it also so one gland actually does not just do one thing. It's interesting how even though we know the pituitary does like 1,000 things, right? It controls so many things, but even the different glands, each of them have multiple functions. They don't do just one thing. It also has to do with secretion of digestive juices and the motility of the GI system. Motility means how that moves and allows the food to keep moving on, right? Now the motility of the GI system also has to do with the vagus nerve and how that part. So there's so many confounding things that happen for the same function, controlled at different levels. And it also helps, it also is connected with excitability of the heart, the nervous system, and vasodilation. What is vasodilation? It is the opening up of the capillaries to allow blood to go into a tissue, right? If there's a vasoconstriction, then those blood vessels at the end point, you have thicker blood vessels, like a branch of a tree, they'll ultimately end up in a leaf, right? So at that leaf level, if everything is constricted, then that leaf will not get the nutrition that much. Versus if it's open too much, all the blood might go in, and there may be better exchange. But what if it doesn't get flushed out? So there's this balance. So the thyroid gland has effects on that too. So disorders of the thyroid gland has to do with this hypothyroidism. That is, there's less secretion of thyroid hormones, right? So what can we expect? If there's less secretion of the thyroid hormones, we can expect that the person may not have that much energy. We can expect that the metabolism is sluggish. It's not quick. So that person might have, might end up having a tendency to become overweight and cold. They may feel more cold, people with hypothyroidism, and they may be more depressed, have more lethargy, and they may be sometimes deficiency of iodine. That's why nowadays they put that iodine in the salt to make sure, right? So that can cause, that's one of the essential minerals, I guess, needed for this. Hyperthyroidism, on the other hand, is oversecretion. So it can cause Graves' disease. It's an autoimmune condition, and it can cause blood pressure, a lot of weight loss, and person is very hyperactive and restless. It can cause a high body temperature. So hyper, and then these are treatable conditions. They do give you medications to adjust that level. So for some reason, the thyroid is not producing enough of that. So it could be the thyroid itself, it could be the pituitary is not sending the messages to the thyroid, because the pituitary has a lot of control over the thyroid.
Or it could
I
be
thought
hypothalamus too. Or it could be hypothalamus too. not
Or it could be the
telephone.
hypothalamus, yeah, because the hypothalamus, yeah. So at any level where this can be controlled, it can be affected, and ultimately at the thyroid level, you know, thyroid tumors is definitely at the thyroid level where it's not producing enough.
I thought is Graves' disease autoimmune? I thought Hashimoto's, the hypothyroid is a
Yeah, but I think it,
condition.
yeah, but I think Graves' disease also can cause, I'm not sure what the mechanism is.
Hashimoto's definitely is
Yeah.
autoimmune.
Yeah.
It's a hypothyroid condition.
With Hashimoto's. So then thymus gland is the gland usually where the two lungs, somewhere that junction is the thymus gland, and you know it has most organs. A lot of organs have the outer part and the inner part, the cortex and the medulla. So you have the similar structure even with the adrenal glands. A cortex is the outer part and the medulla is the inner part, and so and the thymus gland is thought to be have a function, like we talked about it a little bit, right? Have a function in immunity, changing the immunity, improving the immunity. And again, I think the question was when is it most active? Seems like it's definitely active in puberty, but is it also active when in children versus in adults and growing adults? At what point does it not be? Is it not active? And why is it not active? I don't know those answers, but those are good questions on its role.
Thymus, they said
If it is good for
it
the
is active in neonatal, not thymus. That's
In
thymus.
puberty,
right?
right? Yeah.
Yeah. In puberty, it stops and it gets replaced by an adipose tissue. And but
Oh,
still,
really?
Yeah. I just was reading through the Wikipedia and they write about thymus. Basically, they say that it's active until adulthood, but then very small portion of that is useful for some part of that T cells that you are talking about.
So what it's probably doing is it's making that immunity system mature. Maybe it is waiting to produce those white blood cells to a certain maturity level. And then once it's mature, it's not needed anymore, because then the rest of the body takes over the immunity function. Because we still have immunity problems as we get older, right?
That's what I'm saying.
Right?
So
So
if we
the
don't
question
have
is,
thymus, then what?
correct, that's a good, so it's, I mean, just by just, you know, by inference, I guess we can see that it works to mature the immunity system to some extent.
Okay.
And once it's mature, like our bones are mature now, we don't have to do that much more with the bones, it's done. And then, you know, something else takes over with stimulating the white blood cells after that.
So it says by early teens, the thymus begins to atrophy and thymic stroma is mostly replaced by adipose tissue. Nevertheless, residual T lymphopoiesis continues throughout adult life. Some little
Maybe a little.
something, yeah.
So, okay, and then we, so it says, over here it says the functions are largely unknown. So still something, probably they're still doing research on it to see what's going on. Because they, you know, a lot of this research has been done recently where they've wondered some things are vestigial organs not being used. What is the use? Do they have a hidden function and not that haven't been discovered yet? You know, the human body is just so complex. I think they're still trying to find out.
Everything is evolving.
Yeah, everything is evolving, right? Even anatomy is evolving. People are like, there's this new muscle, you know, that you didn't know about. So it's, I think it's the way you look at things sometimes. And and all the functions are changing because people discover things at different levels. Adrenal glands are two glands sitting on top of each kidney. And they're just small glands. They're not like very big, but they're very important glands. What do? The hormones of the adrenal gland, they secrete corticosteroids, which regulate metabolism, growth, renal function, and muscle tone. Okay, the aldosterone regulates the sodium and potassium ion content in the urine, sweat, and saliva. So sodium, potassium, all of this has a lot to do with kidney function also and blood pressure, right? So that determines the amount of the thickness of the blood or the thinness of the blood. And a blood that is very thick usually can be more viscous. It has to do with the viscosity of the blood, and it can cause more high blood pressure or low blood pressure based on how it is. It has a lot of implications. And then the other important part of the adrenal gland is the epinephrine and norepinephrine. It secretes these two, and these are again steroidal secretions that regulate homeostasis during stress. So they are connected with the sympathetic nervous system, also the fight and flight. When the sympathetic nervous system is stimulated, the adrenal gland is stimulated to secrete more of this adrenaline and cortisol. Cortisol is a stress hormone. You're stressed, you're in that pattern of alert. So it's a very good mechanism for us in general. We need to have this mechanism to understand when there's a danger lurking and what to do and be alert about the danger and then escape that danger, right? And the problem with this is it becomes a little bit dysfunctional when, if you're all the time thinking there's danger, then this level of, because it's not meant to have, you're not meant to have high cortisol levels on a regular basis. You're meant to come down and calm down. That's how the body's supposed to be designed. But if, because of modern life stresses, you're always stressed out. You got to pick up the kids, drop them off to school, go to work, fight traffic and come back on time to pick up your child. Then you got to make food. There's just so many things to do. And if it stresses a person out, that level of cortisol level is always going to be high. So you're going to have this heartbeat up all the time. Your basic metabolic rate is going to be changing, and then you may become a candidate for high blood pressure and heart diseases, right? So that's the implication of the adrenal. And so that production of the cortisol or the hormones, the adrenaline, which is the same as epinephrine, okay, is controlled by at the adrenal cortex. But I think norepinephrine is also a neurotransmitter. It is needed to transmit electrical impulses from one nerve to another. So that's another function of norepinephrine. Inside, it's a more limited function inside the nervous system.
So when talking about the HPA axis, the hypothalamus, pituitary and adrenal axis, they say when you are repeatedly stressed, you develop HPA fatigue, HPA axis fatigue. So the hypothalamus is constantly active, pituitary is constantly active, adrenaline is constantly active. So that chain is constantly active at some point, like talking about the norepinephrine. When these neurotransmitters are constantly secreted to handle stress, then the neurotransmitters also
Get depleted.
That's why when an anxiety patient, for anxiety patients, they give SSRIs, right, the new reuptake inhibitors. So we'll probably, when you're talking about nervous system, you want to talk about that synaptic connection and how the neurotransmitters are transmitted from one neuron to the other, and if there aren't enough neurotransmitters, then you can develop anxiety. So when we basically have to connect the endocrine system with nervous system and then talk about all the disorders, and that is when you will probably understand some of what Savita Nanjangood is also talking about, where she brings some of these
the connection of
so
the physiological connection with mental issues. Right? There's a physiological connection, and how with yoga you can, if you can control one of those factors, you may be able to reduce the others. Anywhere in that cycle, if you can try and put a break or reduce the activity, it influences them, because everything is influenced by everything else. So so we have not done the HPA axis and all yet, right? Or the synapses.
You are doing that.
Am I? Okay. So, for example, there's another condition called myasthenia gravis, that also where the neurotransmitter can get depleted. So you have, did you cover the synapse?
No.
The nerve cell and the axon and the dendrite?
No, that's what next will be nervous system. So we are connecting, we are covering the systems and then the disorders. Otherwise, it gets complicated. I don't know how to do this, but it's a vast subject.
Yeah, just a lot. So it's good to know though, because the neuro and the endocrine system are so connected, especially with in yoga therapy. In yoga, it's very important to I think to understand. There's electrical impulses, there's chemical issues, and then the electrical impulses need chemicals to continue to transmit their messages. So ultimately speaking, if you think about it, ultimately it's a very chemical system we are in. Right? There's a lot of chemistry involved, even in nerve, even in the electrical impulses. It has to do with chemicals, it has to do with ions, it has to do with potassium and sodium, and how that exchange changes the action potential. And that's how an impulse is even generated, and then it is propagated in that same way, because there's this connection, there's an imbalance between the potassium and sodium on the inside and outside of the cell membrane. And that's exactly how electrical impulses are generated, and that's how they're propagated. And then they reach a certain point, then that message has to jump from one nerve ending to the next nerve and get processed over there, and that requires again a whole chemical process to happen, right? Okay, so disorders of the adrenal gland. You have the aldosterone imbalance, and excess aldosterone can cause potassium to be excreted, and then that can cause severe muscle weakness. Okay, so and then if there's less aldosterone, then it can go to the other opposite problem. It can also affect the heart tissue. You can get cardiac toxicity. You can get actual cardiac muscle can actually die, and can get fibros because they don't work anymore. So aldosterone has a lot to do with the muscle, potassium. Maintaining the potassium balance in the body. And when we talk about potassium balance in the body, really when you think about it, you're looking at what is happening inside the cell versus what is happening outside the cell. It's intracellular and extracellular. So it's the difference between those two that really causes problems. If there is too much potassium, say if there's not enough potassium in the cell, it cannot do its stuff. So if somehow it's blocked, it's not coming out, it's trapped inside, then you have a problem. And the same thing with sodium and everything. It's really a lot of the imbalances in the body, it's interesting, is because of that cell membrane. It's because there's a cell and something has to happen. That is the bottom part of our existence, is that cell has to work, whether it's a muscle cell or a heart cell or whatever. And for that to work, it has to get enough ingredients coming in, and it has to be able to excrete some things out. That is at the cellular level, right? And a bodily level, we have the same thing. If we keep eating and we don't pass out the stuff, and detoxify, our body becomes poisonous. Our body cannot function. Cells are the same thing at a cellular level. It's just what happens inside and outside the cell that affects the whole body function. So again, with the cortisone deficiency, you get sodium imbalance, and you can get dehydration, and then you can get again blood pressure problems, and this also causes immunity, because the reason it will cause immunity is it can maybe cause an inflammation response with the imbalance. Addison's disease is when it has to do with it could be an adrenal tumor, can cause Addison's disease, and again it can cause issues that have to do with this whole imbalance. A lot of it has to do with the blood pressure, also because it is so connected. The kidney is also right there. Kidney also produces certain chemicals, certain hormones that also regulate the electrolyte balance of the tissues, the blood and the plasma and all those tissues. And all of that has to do with, again, the pressure inside the cell versus outside the cell. Pancreas, or again another interesting, it's a very interesting organ. It's like wedged in between, underneath the stomach, and it's got these islets of Langerhans. An islet is like an island, right? It's like small dots which are islets, which actually produce the hormones. These are the ones that produce the hormones that the insulin and the glucagon that regulate your blood sugar. But the pancreas, the rest of the pancreas also do something. They also secrete something that helps with digestion of fats and carbohydrates and stuff. So the islets of Langerhans, they have the alpha cells, okay, and then they have the beta cells. The alpha cells secrete glucagon and the beta cells secrete insulin. And they do the opposite. Insulin reduces blood sugar. It reduces sugar in the blood. It does not reduce sugar in the cells. You have to know the difference. The blood is just this thing that is washing all over. Cells are each of the tissues, right? So it reduces the blood sugar, is what insulin does. And glucagon increases the blood sugar. So when you have less blood sugar, when you're feeling, glucagon does something in the body. It has to release glucose into the sugar. Now where's this glucose going to come from, right? Usually there's a storage of glucose in certain areas. Sometimes glucose can be stored in muscles. It can be stored in liver especially. So the glucagon goes into the bloodstream and gets connected to for example, the liver, and tells the liver, come on, release your glucose. We need more glucose in the blood, and then release. That's how the balance is made. It's not like
Is it the glucose in the area, or is it fat cells that are broken down to?
it can help with that too.
Yeah.
It can help with that too. It can, through the liver.
How is the opposite done then?
How is?
The insulin.
Well, when there is extra insulin, when there's extra blood, you mean if there's too much blood, it goes out through the kidneys. Usually it goes out, or it is used by some of the blood. I think the excess blood sugar is controlled by the insulin reduces the blood sugar. When so say the glucagon worked and it just poured too much sugar, okay, then the insulin works. So say you have a nice meal with a whole bunch of sugary stuff, your blood sugar is going to definitely will increase to a certain extent, but if it increases beyond a certain level, to produce homeostasis, the pancreas will be stimulated to produce more insulin, and that will then bring the blood sugar down. And yeah, it's a good question. What happens to how does it do that? Is that your question?
Yeah. I mean, where does the influence act, the insulin acts on to bring that blood sugar down?
It gets into the bloodstream, and it acts on the blood sugar right in the bloodstream to reduce it. Now, how does it do it? The actual mechanism, I think it goes to a lot of it is secreted in the. It has to do a lot with the kidneys, right? And I don't know if it converts the glucose to a storage. Yeah, it converts the glucose to glycogen.
It's right over
It
there.
helps.
Next
Oh,
slide.
is it?
It
Oh, there you
promotes fat synthesis and storage, which means that something is getting converted back into fat,
Yeah.
maybe sent
Or
back to the
glycogen.
liver or something.
Back to the liver, probably.
So the liver is responsible for,
Holding the glucose.
Storage.
like, how do liver and the pancreas talk?
Through the bloodstream. It's through the bloodstream. I don't know if there's a nervous connection that controls the liver, but the whole blood goes through the liver. Liver is a filter for the blood, right?
Yeah, it's that there is systemic, pulmonary, and there is portal circulation.
Yeah.
Is it the portal circulation that?
Yeah. So the portal is for the liver. So all the blood goes through the heart and lungs. The same blood goes everywhere. When it goes to the liver, it's filtered, or the liver takes the numbers and takes. So if there's insulin floating in the blood and there's glucagon floating in the blood, the liver takes it in and works. If there's more insulin, the liver might take in and say, okay, let me store. If there's more glucagon, the liver might take in and say, let me release. And it can, control the balance.
Usually I thought filter was more a kidney function.
Yeah, when I say filter, I mean that's how.
Okay.
That's how it does something. But the liver is considered, right? It purifies. It does much more. Liver is it does a lot of things to the blood. The kidney only takes part. Yeah, kidney has to do with the sodium potassium levels, and also too much blood sugar can also pass out through the kidneys,
Yeah.
and also dehydration. If somebody is getting too much water versus less water, if there's someone dehydrated, the kidney will not pass so much. Plus all the other metabolites that are filtered to the kidneys, they go out there, right? And then you have the
Excess albumin also, right?
right. That's why they check your urine so much to see what's going on with your blood chemistry. It gives them a good clue.
Does the liver absorb toxins? Does it kind of absorb toxins?
Toxins is like a general word, right? So toxins is something that your body doesn't want. Toxins could be as a result of metabolism. Something is produced, carbon dioxide is produced, or something is produced that needs to be thrown out of the body, right? So toxins, liver, I don't know that liver absorbs toxins, because those toxins will either go out through the kidneys, and then those things, like for whatever is needed through your food pipe, whatever food you eat is absorbed, and whatever is not needed is of course eliminated, right? And then the rest of the toxins are through the carbon dioxide exchange through air, through the lungs. So if
With chemicals, in like over medications and all that, that's what I heard that
the liver can convert, I mean, I know that it is
It
processed.
also goes in the fat cells, and muscles also absorbs the toxins as well. Adipose tissues takes all the pesticides and everything, depends on the pesticide, chemistry also, it can be deposited on the adipose, or it can burn the muscles. Around all the visceral fat and all, that also does a job there.
So that absorbs some of the chemical toxins that don't go out through these other routes.
Some fat absorbing pesticides.
That's
and
possible. I
chemicals.
don't know that much about it.
So, before we proceed, I just wanted to give one heads up. So, all of these are being done at a 10,000 feet level right now, and that's where probably we'll stay at 9,000 feet maybe instead of 10,000 feet. The idea, however, is after this and the nervous system talks, we pretty much want, and circulatory maybe. Once these are done, we'll have a couple of sessions of just study group like session where a lot of discussions happen. So what I'm going to do now is, next thing is for you to do the assignments. That will be really weekly assignments, no sitting on it for a long time. If we don't do that, we won't get to the study group. Study group being done here itself. So we'll be revising all these concepts, and then you get to take off and study the rest of the things at home before you come for the next semester, right? Next module. So please, you have to work on this. Otherwise, there's no way to teach all of this in the amount of time we have. We need one entire semester just for anatomy and physiology. Thank you.
And this is more conceptual level, to see in general, to understand what different things do, how the body physiology works, and what is needed, and what are some general, right? What can go wrong versus how does it harmonize and work, and just to know some terminology also. The other organs with secondary endocrine function, or also apart from that, there are some other organs also that can do some endocrine functions, like the kidneys. They also help to regulate the blood pressure, right? Then the liver, again. The skeleton also, the inside of the skeleton has a lot to do. The bone marrow does production of red blood cells, and then you're right, Sushma, you said adipose tissue, and the skin, of course, I guess, I mean, I don't know specifically how all the others affect, but everything, there's a secretion. GI tract also has secretions that come into the GI tract to help with the digestion of food. We're doing that anyhow? The next one?
No, we will do the second part later, but we also have to do the disorders. Diabetes, right?
Which one is that?
Diabetes. Part 2 we'll do next time. Then let's go to the diabetes, because today we covered that. What is happening here?
Close it.
Diabetes always becomes a very interesting topic, and more input comes from
Yeah.
the audience than the speakers. I've seen this every time.
So of course, most common
Yeah.
endocrine ailment is diabetes. Right? Anybody here knows anybody who doesn't have diabetes? That would be a question if you're not diabetic yourself. So diabetes is mellitus. So it's a group of metabolic diseases characterized by high blood sugar levels, which basically results from defects in insulin secretion or action or both. So it has to do, again, you should look at diabetes as how much blood sugar is there in the bloodstream and in the liquid outside the cells and how much is inside the cells. And the problem with diabetes happens when there's too much outside and somehow it can't go through to the inside of the cells and do its thing. And so, when there's too much blood sugar in the bloodstream.
Dr. Nagarupna says this very nicely. She says it's like water everywhere and not a drop to drink, right? The sailor said that when there's a lot of water everywhere in the sea, but you cannot drink a drop of that water.
Yeah.
So we are in that similar situation with diabetes. There's
Because
enough
you
sugar
cannot-
outside,
Yeah.
but the cell
But the cell
is not.
is starved of sugar at the same time.
I didn't catch that. So, is that specifically for type 2 diabetes? Because that is what the absorption doesn't take place.
In type 2?
Yeah.
No, I don't know. No, this is in general. This is a
Village.
general thing that there's diabetes, whether it's insipidus, whether it is type 1, type 2, is a condition where there is just too much sugar in the blood. And something is happening which is not getting processed. Most likely it's insulin driven because either insulin is not getting produced or I don't know if the blood sugar is not being able to be driven into the cell
That's
to be
type two.
used.
So type 1 is a deficiency.
Yes.
Deficiency of insulin.
Insulin.
Type 2 is inefficiency.
That is the absorption.
So insulin is
Ah.
there, but it's not.
Yeah.
It's not going through the cell membrane,
Yeah.
right? It's not going through the cell membrane and it's not.
So the
enough is not
receptors,
getting
the receptors
created.
at the cell
It's
level,
not getting created.
they are supposed to
Insulin
take
is not getting
insulin,
created,
and
right?
they are
No, yeah, it can be insulin is not getting created. That is
Or
one
it
level.
can be
Yeah.
insulin.
Or it can be that even if insulin is created, even if insulin is created, the blood sugar is not going through the cell membrane into the cell.
Okay.
Something is blocking it. The
Insulin
receptors.
resistance, they say.
Mm.
The cell is not taking the insulin.
Oh,
The
it's not able to
receptors for
absorb it.
insulin.
Yeah.
Okay.
So you
Yes.
can keep putting a lot of insulin, maybe, and then it's still not going to go through.
I see.
The resistance, the barrier becomes maybe too thick or something, and it's just not going through because the cell is starved of the glucose. But there's a lot of glucose sitting outside the cell.
Right.
It's not going through the cell membrane.
And they say for a diabetes person, even insulin in the blood sugar is quite high.
Type 2. Yeah, now I think I got the confusion. I was confusing between absorption of sugar versus absorption of insulin. Very,
Yeah.
very different things.
Yeah. In fact,
Yeah.
this
Because
insulin.
insulin is not
resistance.
absorbed. Insulin is poured into the.
The receptors, like they are not sensitive to.
Yeah, it's not. Yeah, so the blood sugar is just not able to go through inside the cell.
So sugar molecule is need to be carried inside the cell by an
Insulin.
molecule.
Yes.
So the sugar cannot just go inside the cell on its own. It needs to be carried through the cell membrane.
correct.
And then there is resistance to that insulin, so that it cannot go through. And
So then how does it get
So the
corrected?
cell does not have any energy now because none of the sugar
Yeah.
molecules are getting
cell
into the
needs
blood.
energy
So
from
that's
there.
why you feel tired.
There is
It's
enough
too
sugar,
high.
there is enough insulin,
Yeah, but it's
but
not
nothing
getting
goes
absorbed.
inside the cell. I mean, for the most part.
So it's two conditions, isn't it? One is insulin is not being produced by the
Yes.
Yeah.
pancreas,
Yes.
another is like receptor is not
Yes.
working.
So that's why somebody with diabetes may be given two medications to
Or
reduce the
one to work on that
insulin
level
resistance
onto
Ah.
and to increase the insulin. They may be doing one of two. If the pancreas is not producing enough insulin, then they may give you a medication that increases the insulin. Or they may give you a medicine that increases the cell sensitivity so that it will become more sensitive to the insulin.
So we
Like
know
people take
why it
insulin
happens.
injections
Huh.
when with severe
That's when
diabetes.
insulin completely
is depleted.
is depleted.
So pancreas are not producing insulin,
all.
most likely.
Yeah.
Well, most likely,
Yeah.
for whatever reason.
Yeah.
And then they have to have that insulin regularly to process everything.
So
Do we
the
know what
opposite
it causes?
happens is there insulin resistance. Then what can you give them?
So they do. That's why they give you two different types of. They'll give you a different type of medication. There are medications that address lack of insulin,
Okay.
and there are other medications that address the cell sensitivity to the insulin.
Okay.
Right? Anybody?
I do not
Yeah.
get. I don't know this.
But do you know what it causes? Why pancreas is stop working and why receptors are not working? What could be the wrong in the body that it's happening? At the cell level, genetic level, what's really happening there?
Can I take that?
Yes,
So
please.
there are two situations. One is obesity can cause the number of cells that are in the body for the pancreas to handle is too much.
Mhm.
So the pancreas produces what it produces, but then that's not sufficient for this huge body. That's one possibility.
But pancreas is working fine, the only thing is not sufficient for...
It's not sufficient.
Okay,
Yeah, that's
yeah.
one. Then the cells themselves become less efficient in absorbing or having the carrier, like she said,
Yes.
right?
Receptors.
That receptors, yeah. The cell receptors to get the molecule of sugar along with that insulin as the agent, the carrier agent. That mechanism is not working very well. It's not failed. It's not
Because of
working very well.
Because of the obesity or just...
Can
happen to
anything.
everyone?
It can be
Okay.
simply fatigue.
Okay.
Too much sugar, too much of processing
Stress.
insulin. It's like you said, it's just stress for whatever bad lifestyle can be anything, or it can be simply even mentally driven, right? Where you are putting this HPA axis fatigue can result into, look at that, hypothalamus, pituitary, and adrenal.
Adrenal.
Any of this chain, right?
Mhm.
That pituitary especially, controlled by hypothalamus, has the capacity to work on all glands, and somewhere if that fatigue has happened, something within that chain will break. So that is why the cells are now no longer well enough. They don't have the mechanism to get the proper receptors. Somewhere chemically something has messed up. But at the same time, with yoga, initially will immediately see the results with respect to sugar levels, where the sugar levels become pretty nice, and it may not be completely healed, but it becomes quite manageable in many cases without even medicines. People who are pre-diabetic or just initial diabetes can just start working on yoga and mindfulness and relaxation and whatnot. They don't even need medicines at all. With proper lifestyle and yoga, they can live without all these
See,
medications.
muscles are very important in processing blood sugar. Muscles are a huge part of. They help the pancreas in a way to process blood sugar. They can really. So that's why and I don't know exactly the mechanism. I think first of all they can take extra glucose and store it, and then the other thing that they do is they process the glucose and they improve I think they improve the cell sensitivity to the insulin receptors. So that is processed more efficiently when you use muscle tissues. So that's why they say it's good to exercise after, it's like another organ that helps you process blood sugar in a very good way, in an efficient way. So
Is there any diagnosis tool that which can find out where the problem is exactly happening in the body? Suppose somebody is somebody says it's diabetic. So where it's like pancreas or cell is not working or receptor is not working, have they any diagnostic tool?
It can be a mix of everything.
Or it can be so they don't know exactly. They just kind of.
So you're saying, do they try to do some tests directly on the pancreas?
Or something,
to see?
some like tool they have developed anything that it says exactly where the problem is, so that you can have a targeted intervention wherever possible.
I think they assume
Even in
the
the yogas,
they
where we
assume
do
the
it
problem
place
is the
where it's
pancreas usually. They assume that the problem is not enough insulin, which is coming from the pancreas, and then I don't know if they do specifically to see is it usually there's a pancreas, that is a problem. I think they make that assumption, but I don't know. Good question. I don't know that they.
Can we bring up hereditary here?
Yeah, so there can be a genetic connection, right? You can have the propensity for developing diabetes, and but if you have the right lifestyle, if you do the right exercises and the right, whatever things to counter that, you may be able to.
So it comes with the DNA, what you carry from your
It can. I know certain doctors actually feel that no matter what you do, you are going to get diabetes at a certain
Yeah,
age.
that's what they say.
Yeah, that's what they
Is there
say.
a way to get over that?
Yeah.
If you're sure that your family had, but if you start doing, taking your
Yeah.
due diligence on it.
What you can do, they say that you can delay it. You can delay the onset for more years.
But they say
But you
DNA
may
can
not-
be changed too,
Yes,
You
yeah.
can change it into the DNA level if you start practicing.
Correct,
it.
epigenetic.
That's what they're
Epigenetics.
talking about it. That's what they're talking about.
Epigenetics.
That's the
Yeah.
epigenetics. Where
Yeah.
you do, there's a mutation that happens. It just, you don't know at what level, and you don't know if the mutation will happen in your body in your lifetime versus in
The next generation.
the next generation.
And recent study shows that blood sugar levels, each person is different, depending on their body, how it reacts. For example, older people, right? So if it's like, for example, 80 years old, so generally 100 plus 80, they can have 180 blood sugar, which is normal for the people that age.
Yes. Yeah. Also remember, the muscular system has a lot to do with processing blood sugar, right? So if you make a connection between a growing person, right? As when the person is young, they have lots of muscles in their 20s and 30s, they're muscular. But every 10 years, you lose 10% of your muscle, right? So by the time you're 50, 60, you've lost, 30%, 40% of your muscle bulk as compared to when you were at the peak. So your capacity to process that blood sugar is less. And your body meanwhile has also degenerated. Everything has become fatigued and weaker and stuff. So that's like a double whammy. You've lost muscle, and so what she said makes sense, that sometimes it's kind of normal for older person to have a slightly higher blood sugar level because they don't have the same muscles to
But
process.
they no need to take medication too, because. that's
Right.
what
So they
we-
consider that normal. They
Yes,
consider
that's
that.
right,
Who is they?
Like,
80 plus.
for example, if you are 60.
No, who is they?
Doctor.
Doctors, generally,
No,
like.
not these
80
days.
80 years old people have 180 blood sugar. That is common for them. They don't need to take medication.
Says the doctor?
Yes.
Okay, that's good. Because that's what Indian medicine system usually says.
Mhm.
Here
Even
it's
if-
all,
Yeah.
the numbers are set and it's
Yeah.
just.
No, now it is changing. I think. I
Yeah.
think you're right. They're saying that for certain age levels, they start creeping up a little bit, where the acceptable margins are a little bit
Yeah,
higher.
70 years, 170 is fine. 50 years, 150 is fine. 40 years, 140 is fine.
That's
100
not
plus.
what they say,
Yeah.
I guess.
No.
I don't think so.
here they don't say.
Here, but that they are changing the things. But in general, usually Ayurvedic doctors and other doctors say.
Not here, not here. I can bet you that not
Not
from.
Not that much. That's a little bit
Not that
drastic
much,
here.
yeah.
Right?
Yeah, not here. Yeah.
Yeah. One other thing about diabetes I just wanted to say is that Dr. Sudha Rajan in Houston, she's an expert in diabetes, and we'll arrange an online talk by her. So some of the questions I'm seeing, what are the different causes? Do the doctors go into all different causes
Yeah.
and see whether
Your
it is
question.
diabetes mellitus or insipidus, or she says there are 8 causes of diabetes. It's an Ashtavakra disease, and whether one factor or more can be involved. And she says yes, a thorough investigation is required, but doctors don't do all of that in most cases. And they simply label and move on. She highly recommends that you take ownership and possibly find out. And of course, even if we don't find out, you can pretty much say that yoga is a one size fits all. You can just
The set
Yeah.
of asana,
Good lifestyle.
the practices that we did today, it's a one size fit all as well. Like we,
Yeah.
as from our perspective, we don't care, not care, but we don't, not concerned whether it's this type or that type,
Yeah.
but it's
Correct.
diabetes.
You're right. We don't
And any,
really concerned too much.
like so when a patient comes in, so since I don't know anything about sugar, I don't know anybody who has sugar in my family, so they already come with their,
Lucky you.
pardon?
Lucky you.
Okay.
Good
Very
genes.
few are like that.
Yeah.
Yeah.
Your family, nobody has diabetes.
No, yeah, I don't recall anybody. So they come in and then they come in already with the tests done, right? And then is there a way that, do they bring their own sugar monitors and then check during the class? And
No.
I'm just concerned if they faint and stuff like
No,
that.
no,
What happens
no.
at that point to the sugar
They
level?
sign a disclaimer.
Oh. No, I'm just thinking from our side, what are the cautions that we need to take?
Disclaimer.
I think that's a good question because I have
Because
seen that
I-
happen in one of my
Correct.
classes.
I would be
Correct.
scared,
Sugar level plummets.
not knowing anything
Oh.
about this disease and not knowing, I mean, obviously.
That's why in the yogic management we said, right, that you are going to tell them to monitor their sugar levels as they practice yoga.
So
Same thing with
that's not in class
hypertension.
though.
Not in the class.
You know, when I
They
started,
do consider them big their own. Yeah, I don't know how it's
when I
done.
started my clinic,
How did it
my
sound?
first
Okay.
patient who came in fainted on me.
Oh.
My first patient.
Wow.
She was a Medicare patient and she came in and I did the evaluation and suddenly she just dropped and I'm like, oh my god. I was alone in my office. I called 911 and I took care. I said, I checked her pulse and everything. They came within 5 minutes. They took her off. Then next week she comes back smiling, saying, I thought she had a heart attack, right? I thought she had a stroke because she fell on one side, right? But she was breathing and everything. And then she comes back the next week and she's happy. And I said, what happened? Because I had called back and nobody called me back to see what's going on. I'm like, oh my god, what happened to this woman? My first thing, this is a sign. I'm like totally sweating. I don't know why I opened it and I should have a partner. And I had all these things going on in my head. I was like really upset, And she comes back next week and she says, oh no, they just gave me some blood sugar and I'm fine. And I went home the same day. So she had not had her breakfast. She had not had her dinner the previous day and she happily came for therapy.
This was after the therapy?
Huh?
This was after the
No, halfway through. I was just doing an evaluation and I said, I had not even started much. And so it was like a really scary experience. But, the point is you can ask them. Any diabetics here, have you had something to eat?
Do you know how to manage your own
Yeah, do
disease?
you know? Yeah,
That's
you
very
can maybe
serious.
just find out.
That is something to do.
Especially if you're doing yoga therapy, you should know, hopefully you won't have 60 people in your class, right? You'll have a small class or you'll do one-on-one. And when you know that, you kind of know when someone's looking off, when they're getting hypoglycemic, you kind of know. They keep checking out, right? You'll just say, then you can make sure they have
that happens to people who have severe diabetes, right? I mean, they will know that their sugar, they have
Yes.
tendency for their sugar to go down. So in those cases, sometimes we do private classes, one-on-one, give the
Yeah.
treatment.
But people need to take ownership of their diabetes. If they have diabetes, they better know. They better not come to the yoga class on an empty stomach after not having 2 meals. They should know better. If they've had diabetes for a while, they should know that
But
they can't do
you
that.
are there and they expect you are a therapist. They expect you to do something at that time or you should
No, you can't do
a
anything.
background to really know what you
No,
should
you
do at
can't
that
do
time.
anything. If they
No?
faint on you, you call 911 and
Yeah.
make sure they're breathing
Not
and
not
give them
anything like
CPR.
that, but
Make sure you have your
something,
CPR certifications.
Yeah, we
Yeah,
by the
something
way,
you have to know that
it
how
is
to
mandatory.
manage it.
It's
Yeah.
mandatory for yoga therapists to have
CPR certifications. Make sure
Exactly.
you
Something
have
you
that.
have to know because you are sitting as a therapist and something going with your patient and you have no clue. You cannot say, oh, I don't know anything.
Yeah, you get you start using CPR, ask someone else to call 911, check their pulse, have that person on the phone, they'll guide you if you don't remember what you're supposed to do. And
Yeah, in India there is a famous doctor, he's a nutritionist, so he cured actually Bill Clinton some problems and he's cured more than 100 people, diabetic people. So maybe if you get a chance anyone you can check. Dr. Vishwarup Chaudhary.
In Calcutta.
I don't know Calcutta, but it's, yeah, Vishwarup Chaudhary.
Good. Okay, so again, type 1, type 2, then there's gestational diabetes, right? That's temporary. That happens just during pregnancy and then it goes away. And again, type 1 is results from body's failure to produce insulin and requires the person to inject insulin. Typically, it's detected in children, type 1 diabetes. And it's really, really hard for children. You know, it's painful and it's really tough for these kids to be, they can't help it, right? It's basically there's just no insulin
So,
production. It's not a lifestyle thing for them.
so type 1 diabetes, it would come in the adults?
No, they can continue having it.
No, like for
No,
example-
type 1 is only in children, as far as I know. It's detected in children and then it's treated right from childhood onwards.
Okay.
You know, so it's something you really can't do. You want to teach them still good lifestyle habits, right? Because it can get worse, and so because they don't have the insulin, they still have to take it, but they have to control their tendency for obesity. They still have to have a good lifestyle and good eating habits to continue that. Type 2 is results where the pancreas does not produce enough insulin levels, or the cells don't respond to the insulin, one or the other. It could be cell sensitivity, and it could be the actual production ability of the pancreas to produce insulin. And then gestational diabetes is when the body of a pregnant woman cannot does not secrete enough insulin required. So that increased blood sugar can go to the child also, so they want to make sure they take care of that.
What was the third one you said goes to the child?
Gestational, during pregnancy.
Oh, during, yeah.
So cause of diabetes, type 1 is there is no insulin. The islet cell just doesn't produce it for whatever reason. Type 2 is there is insulin, but insulin is not enough, A, or B, there is insulin resistance at the cellular level. Does that make sense? Okay. And then you have the gestational diabetes. Type 1 hereditary, and it could be an autoimmune condition. Type 2, there's a hereditary, it's a 25% chance that one person has type 2. Asian Indians have a high prevalence in general. It's an epidemic in India.
Yeah, it is. It
It's
is the
crazy.
only in the whole world.
Yeah,
India stands out first.
yeah. India, and you know, and we don't, you know, in India they eat, actually thinking of the meat consumption, now we eat less meat. I think we, you know, carbohydrate and lifestyle. The lifestyle.
Yeah, carbs and sweets.
Yeah, yeah. Then the age, again, like you said, right? The body functions just kind of deteriorate, and so the ability to process insulin may reduce. Insulin sensitivity might increase. Pancreas also kind of, everything degenerates a little bit with age. Everything is not, you know, so then overweight, and then of course the diet and lifestyle can enhance the problems of diabetes. What is autoimmunity? So it is capacity to differentiate the self from non-self, and it is disturbed in diabetes and white blood cell attacks, where the white blood cell attacks the beta cells. So when the body, our body is normally designed to only attack foreign invaders, but sometimes the body does not. That's an autoimmune condition. Is when the body attacks itself, thinking it's, so the body can itself cause inflammation in the beta cells, thinking the beta cells are foreign, and so then they cannot do their work and produce insulin, and they can cause a little bit reduction in the. There's still a lot of research being done, I think, in this area on how much is the autoimmune factor in diabetes. But again, you know, if you think about it, you generally, a person who has the HPA axis is really, you know, crazily active. So there's lots of cortisol levels. That means there's a lot of inflammation going on in the body. Then the body can get confused and start attacking different parts, and you can get more tendency to, you know, even the diabetes can be enhanced for that. And then the other one, it says the same thing, autoimmunity. So the white blood cells senses an invader, right? And then it sends out all these its soldiers to fight, and that causes inflammation. Inflammation is a response of the body to some kind of injury, or when it thinks something is wrong, it sends out, it causes swelling in that area for a reason, to do some repair work, because and to get rid of that foreign invader. But if there really isn't, then they are attacking their own cells. It happens in rheumatoid arthritis and lupus and some other diseases. Then you have the chemicals. Again, chemicals are released that, and then you have the inflammation that takes place. Okay, what are the signs and symptoms of diabetes? And the signs are kind of subtle. You know, you sometimes won't know you have diabetes. You go to the doctor, they say, okay, you know, sometimes you may have, you get up in the night, frequency of urine, increased thirst, weight loss, ketone in the urine, irritability, fatigue, blurred vision, delayed wound healings, increased infections. A lot of this can happen a little bit down the road after you've had diabetes. But before, you can be pre-diabetic, right? It's not easily detectable necessarily. You know, maybe, you visit the bathroom more, frequent urination, maybe, but maybe not. So a lot of times diabetes is discovered just when you have your regular annual checkup, and then the doctor says, you know, a little bit high, let's check again. Then they decide, okay, let's do your fasting blood sugar, and then they say, yeah, looks like you're pre-diabetic or you are diabetic. And then as that continues to happen, more of these symptoms start showing up. Risk factors for diabetes type 1, genetic factor is the highest risk factor. I don't know about the others. It says environmental factors like viral infection, autoimmune factor, diet, geographical factor, I don't know about that, and then bone deformation and rheumatoid arthritis. So these are so people who have some of these issues, I guess, may be prone.
Type 1, sometimes they say that it could be virus. They don't know what's the factor. These are all speculations for the most part. I just lifted from wherever it was and just put it here.
So there may be an association with these things. It may be that somebody who has type 1 maybe also has some other autoimmune condition going on, or has the propensity or to have another maybe rheumatoid, because you can have kids with that condition too, right? Then for diabetes type 2, race is the biggest one. Again, I think Indians, I think we have a high tendency for diabetes. I think African Americans also do have that. So certain races are more prone to diabetes. Again, weight and sedentary lifestyle and weight, family history. Again, the genetic part, the age, as you get older, the chances of that is higher. Elevated blood pressure and cholesterol. That could be a risk factor, or it could be the opposite. It could end up, somebody with diabetes will also have, it's an associated factor probably, may have the tendency to also have these other issues, cholesterol and blood pressure issues. And then polycystic ovary syndrome. Again, that's sort of like a autoimmune thing, right? That's some autoimmune connection with it.
Hormonal also. Hormonal.
And hormonal.
We don't know.
Yeah.
All possible causes, but basically just to bring the perspective as far as not medical perspective, but look at the social perspective. The lifestyle, diet, the kind of work occupation, all of them were related in, just about 50 years ago. A person in India, busy at work in the fields, eating a certain type of food, not filled with sugar and fat, just the usual sattvic food or whatever local food. But now all of that has changed with the entire so-called green revolution, right? It has become really a red revolution, if you ask me. So now that has brought about change in the diet and lifestyle, and the occupation. All are in disharmony with each other now, especially talk about African Americans. They are all obese here, but if you go to Africa and see them, they are not going to be looking like the way they are looking here, because they have been displaced from their geographical location, and they are no longer doing what they were otherwise doing in Africa. So things are all changed, and the diet is, forget it, you don't want to talk about it. So that kind of lifestyle, everything is in disharmony, and that has become the major factor. So it's not like they have it in their genes. Eventually now they have it in their genes because
of the epigenetics.
Now epigenetics, right? Because of the stress through all of these factors, it has got into the epigenetics of it. This is my personal solution.
No, it makes sense. Like for example, in the slave traditions, they were not even able to eat what their masters ate, right? They would eat only the leftover stuff, which was really bad stuff. But they, so that kind of food was not healthy. Then of course there were stresses. They were stressed out all the time. So, and then
and now,
psychologically suppressed.
Look at the food they eat, right? The burgers and all the junk food is full of sugar and fat. That's all there is. Thank you.
And here again, women risk factors. Again, these are associated with gestational diabetes. So women older than 25, again, overweight before pregnancy, family history, and race all have impact on gestational diabetes. Okay? Complications of diabetes. Of course, diabetes is a whole body. It can affect all organs. And it can affect your eyes, it can affect your nerves, it can affect your heart, right? It can affect your kidneys, it can cause foot damage because it affects your skin receptors. Because somehow that blood doesn't reach, there's not enough perfusion. It can be associated with infection of the skin, hearing impairment, and then Alzheimer's disease. I don't know about that connection that much, but is there?
Yeah, pretty much.
With Alzheimer's?
All of these are
diabetic.
Again.
But it can affect the blood supply. It can affect every organ in the body. That's why it has multi-level implications. It's a dangerous disease and it's a silent killer, right? It's not something that it doesn't show up right away. It shows up over the years. Again, what are the tests that they do? They have the hemoglobin A1C, the glycolated hemoglobin test that shows you an average sort of the last 3 months or so. They do random blood sugar tests, and then they do the oral glucose tolerating test, and these are some of the numbers that it shows. Usually they look at it before eating and after eating, right? So then again, based on causes, you have gestational diabetes and secondary diabetes. Maybe like pancreatic tissue is destroyed, and then diabetes due to hormonal disturbances. What's the treatment? Usually right now the treatment is medication, right, and lifestyle changes, and they do insulin is one medication, but they have a lot of new medications nowadays that do a combination of things to increase the insulin versus to increase the cell sensitivity. So they give you combination therapy for that. And then yoga therapy falls into this because it teaches you to control your lifestyle and teaches you a long-term approach to this condition, so you can control it.
This medication will have a lot of side effects.
Right. Most medications will have something or the other, right? And then you want to.
No, I think we have done.
You've done this. So this is again taking into account the different koshas at the different levels, how you can work on different levels and then influence. The influence. If you have diabetes, you can influence that by doing, by really addressing not just the physical aspect of your lifestyle, but also to address the different koshas at different levels, and all of that together can create a nice integrated approach to treatment. Should I just keep going on this?
Yeah, thanks.
And we did this, right? Okay. I just
Should I use this mic?